In the lesson today, we're going to be talking about the surface area of cylinders and spheres. So unlike finding the surface area of right prisms, the surface area of cylinders and spheres is solvable using formulae. So that means it's actually a lot easier than what we were doing with right prisms. And of course, there's lots of different types of cylinders that you can consider, such as a toilet roll. And then there's also things like for spheres. I've put a jam donut here just to keep the food theme alive, just making sure we're all hungry all the time. So I've broken this lesson into two parts. We're going to talk about just the cylinder, and then we're going to talk about just the sphere. So to find the surface area of an open cylinder, which is like a toilet roll, all we're going to be doing is finding this part here. So not the top or the bottom, because we're considering that to be open. So the surface area for that is 2 pi RH. And that is also how you find the curved surface. So if you ever asked to find the curved surface, it's the same as finding the surface area of an open cylinder. And if you're wondering where that formula comes from, it's the circumference of the circle, and then you times it by the height. Because if you fold this out, it ends up being a rectangle. So it's the same as a base times height situation, but the base is 2 pi r. If we're finding the surface area of a closed cylinder, that's the same as finding the curved surface. So the surface area of the curved surface plus the area of the top circle plus the area of the bottom circle. So the formula is going to be surface area is 2 pi r squared plus 2 pi r h. So the area of the bottom is pi r squared and the area of the bottom is pi r squared. So because there's two of them, that's why in the formula we have 2 pi r squared. And then the curved surface is the same from the open cylinder. So now we're going to apply that into an example. So there's two parts to this example. A closed cylinder has a diameter of 32 millimeters and a height of 50 millimeters. So for part A, we need to find the area of the curved surface. So remember, whenever we're told to find the area of the curved surface, it's like it's an open cylinder. Even though the question says closed, we act like it's open. And then for part B, we need to find the surface area of the cylinder. And we have to make sure we're answering in square millimeters correct to 2 decimal places. So because we're finding the area of the curved surface, we need to use the formula 2 pi RH. So because we are just using a formula, we just need to substitute, but we have to be careful because we have been given the diameter. We need to use the radius. So we need to halve 32, and that will be 16. So when we put that into the formula, we're going to have 2 times pi, which comes from the formula, times the radius, which we worked out is 16 because it's half of 32, times the height, which is 50. When we type that into our calculator, we get 5,026.5482, and it goes on, because remember, whenever there's pi, you're going to have lots of decimal places, but we only needed to 2 decimal places, so it approximates to 5,026.55 square millimeters. And that is the surface area of the curved surface. But for part B, we need to find the surface area of the cylinder in total. Now you could take your answer from part A and then add it on to the formula, but we're just practicing using the formula at the moment, so we're going to use the closed cylinder formula, which is of course 2 pi r squared plus 2 pi r h. Just like before, we need to remember that the radius is half of this, which is 16, and then we just substitute all those values in. So 2 times pi comes from the formula, times 16 squared, because that's the radius, plus 2 times pi comes from the formula, and then times 16, which is the radius, times the height, which is 50. When you type that into your calculator, you get this value, and to 2 decimal places is 66,635.04 square millimeters. So now we're going to talk about the surface area of a sphere and hemisphere. So with the surface area of a sphere, we have to remember that it's basically the area of a circle, but then just times by 4. So that's the surface area is 4 pi r squared. And of course, if we're talking about the surface area of an open hemisphere, it's just half of it, which is why it's 2 pi r squared. And interestingly, if the hemisphere is closed, that means that this is like, at the moment, we're considering this like a bowl, just upside down. But when it's closed, it's like a dome. So that would be closed off, and the area the surface area becomes 3 pi r squared. And if you're wondering where that comes from, it's the open hemisphere, which is 2 pi r squared, plus the area of the base, which is just pi r squared because it's a circle. So if you add those two together, you get 3 pi r squared. So if it helps you remember, pi r squared is a circle. Open hemisphere is 2 pi r squared. The area of a sphere, closed hemisphere, is 3 pi r squared, and the area of a sphere is 4 pi r squared. So it just keeps on going up by 1. We're going to use that as an example now. So what is the total surface area of 1 dozen tennis balls? Each ball has a radius of 3.5 centimeters, correct to the nearest square centimeter. So first of all, we're talking about just the whole tennis ball. So we're going to be using the formula for a sphere. But we also have to note that it's 1 dozen tennis balls. So 1 dozen is the same as 12. So we need to, no matter what we do, we need to times it by 12. So the surface area is going to be 12 lots of the surface area of a sphere, which is 4 pi r squared. We know what the radius is, it's 3.5, and that's the only variable that we need to add in. So when we substitute that value in, we'll type that all into the calculator, and we get 1,847.256, and it goes on. Remember, the reason why we're adding so many decimal places is to show that we know that it keeps on going, even though they only ask for the nearest square centimeter, which that is our approximated answer. And that brings us to the end of this lesson where we talked about the surface area of cylinders and spheres.